Good evening, everybody, and welcome to the virtual public informational meeting for state project number 44-161, replacement of bridge number 5623, Colony Road over Latimer Brook in the town of East Lyme, Connecticut. This live event is available on Zoom and on YouTube. There is project content information below, including email, monitored voicemail line, and we encourage you to visit the project webpage. This is a brief overview on how to access closed captioning and subtitles in Zoom. On the bar below, there'll be a caption button, and you can select your speaking language or the language from the list shown. Closed captioning, including non-English translation options, are available on YouTube after the event. During the Q&A portion of the Zoom, you can access the Q&A window through the button below on the toolbar, and a member of the panel will be able to answer. If you're an audio-only participant, please dial *9 to raise your hand. My name is Mark Burns, and I'm the project manager for the local bridge program at the Department of Transportation, and this is my contact information. Goals for tonight's meeting will be to interact with the project team, to explain the federal local bridge program's Design Managed by State, or DMS program. We'll have welcome remarks from the town of East Lyme. We'll introduce the project team. And then there'll be a formal presentation of the design progress, which will also explain the condition of the existing bridge and define the purpose and need and show our recommended viable proposal. Please bear in mind, our design plans are at only 30% and we are still soliciting input from the public. Following the formal presentation, there'll be an open forum for your questions. To reach the project team, you can access us by email at dot-flbp@ct.gov, by phone at 860-594-2020. This is the monitored voicemail line. During the Zoom event, you can access us through the Q&A. And again, you can reach out to the project webpage. Please note that the comment period is open until August 19th, 2024. This slide is regarding Title VI civil rights. No person shall, on the basis of race, color, or national origin, be excluded from participation or subject to discrimination in the development of this project. We highly encourage you to fill out the voluntary post-meeting survey located at the QR code and web link below. There's also another link to the department's civil rights information through the Office of Equity. The recording of this presentation will be posted to YouTube after the event, and closed captioning, including non-English translation options, are available on Zoom and YouTube. This is another slide regarding Title VI notice to the public. So this project is funded through the Federal Local Bridge Program, Design Managed by State, or otherwise known as the DMS program. In the past, the Federal Local Bridge Program was an 80-20 split. The department would use 80% of federal dollars, and the town would match 20% for design, rights of way, and construction. In DMS, design, rights of way, and construction phases are funded with a minimum of 80% federal and a maximum of 20% state funds. So the full cost will be at no participating. There'll be no cost to the town for design, rights of way, and construction. And even though the department is undertaking the design on behalf of the town, it is still a full partnership, and we coordinate with the town at all key project milestones. The goals of the DMS program are to provide a streamlined approach to design using full DOT resources, to aid the towns to keep the bridges in a state of good repair by effective use of funds, decrease typical design time from 60 months plus to 24 to 36 months, and when applicable, utilize accelerated bridge or ABC techniques to shorten construction duration. I'll now turn it over for some remarks to Dan Cunningham, First Selectman for the town of East Lyme, and Joe Bergaw, Public Works Director for the town of East Lyme.
Oh, good evening. Thank you for the opportunity to address those that are interested in this project. First, I want to thank DOT for finally putting it together and getting to this project in the most efficient way that I think you can do it. It's very important to that neighborhood. We live in a time of climate change and a lot of big storms that have faced us, and this will certainly create a safer area for the Colony Road neighborhood. We're certainly willing, we're happy to support DOT in this project, and my office is open to field questions. If someone has a concern and they have a question, feel free to call my office. The number is there on the screen, and we'll make sure that question gets directed to the right department so that it can be answered and allay any concerns that someone might have. So again, thank you, DOT, and I'll turn this over to Joe Brook, who has a lot more information that I think you'll enjoy hearing.
Well, thank you very much. My name is Joe Regan, the Director of Public Works in East Lyme, and I appreciate the people that are interested in this project. I want to assure them, as the Director of Public Works, that we will be working hand in hand with this team. They've been great to work with, the state, the federal partners, CGM, our liaison. I'm very familiar. I want to make sure this is right, because this is my neighborhood. I grew up, for those of you who are not aware of this, on 16 Colony Road at the corner of this bridge, and so very familiar. I moved, that road was built in went across the bridge in 1968, and that's when I moved there, and I was there till 1993. So very familiar with the neighborhood. We want to make sure it's right. I still know a lot of the people up there. We're going to be working hand in hand with the DOT to have this a successful project. And if anyone ever has any questions, come reach out to the town, and we'll make sure we get them answered. And it's going to be a successful project, and we're looking forward to working with these guys. So they have a lot more information, so I'll let them speak.
Thank you, Dan and Joe. I'll now introduce the rest of the project team from the department and from the department's liaison, Close Jensen and Miller. Bart Sweeney is our division chief of bridges. Derek Lassard is principal engineer of the consultant design group. As I said, I'm Mark Burns, project manager. Jeff Organic is project engineer. Representing the Office of Rights of Way is Zachary Garino. Representing Close Jensen and Miller are Jim Playtosh, project manager, and Jim Otis, project engineer. This is a brief slide showing the structural elements of a bridge. In this case, it is a culvert because the existing bridge is also a culvert. The roadway is what all vehicles, pedestrians, bicycles, etc., would be traveling on. And underneath the fill or ballast would be the culvert pipe, which will act as the structure. And then at the outlet, you'll see an end wall and usually wing walls. There'll also be a pipe invert for the inlet and outlet. Bridges are also rated on a scale of 1 to 9, with 9 being in excellent condition and 1 being an imminent failure. But if there was any instance of any severe condition, the department's bridge safety unit would alert the town to take any necessary action. This is another slide showing bridge structural elements. The deck, otherwise known as the roadway, is the main traveling surface. Then parapets will act as a barrier to present any roadside hazards. Supporting the deck is the bridge superstructure. In the case of this diagram, is steel beams. Supporting the remainder of the superstructure is the substructure, which in this diagram is abutments and piers. Depending on the span of the bridge, there'll be 0, 1, or more than 1 pier. And then for earth retention, there will be wind walls, similar to that in the culvert. And then there will also be substructure elements that will either be a footing base or a pile supported base. Here's an elevation view. As I was saying in the prior slide with piles, that's what this is showing. That piles will be drilled into competent bedrock that will act for scour, prevent scour and help with forces. I'll now turn over to Jim Otis for the formal presentation. Jim?
Thank you, and good evening, and thank you all for attending this public informational meeting for Project 44161 in East Lyme, Connecticut. This bridge replacement project is located about 1.25 miles north of Route 1 and about 1/3 of a mile east of Route 161, which is also called Chesterfield Road. Bridge 5623 carries Colony Road over Latimer Brook. Colony Road is classified by the Connecticut Department of Transportation as an urban local road, and it has an average daily traffic volume of 322 vehicles per day. As you can see on this aerial photograph of the neighborhood, this bridge is located in a residential neighborhood, and there are no sidewalks on or near the existing bridge. The bridge itself consists of twin metal pipe arches, which you can see in the photo on the left side. Each one of those plate arches has an opening width of 16 feet, and the opening height is 10 foot 1 inch. The arch on the right side of the photo was reportedly built about 55 years ago, as Joe mentioned, in 1968 or 1969. The other arch that you see to the left side of the bottom photo was installed in 1983 after the roadway overtopped. The approach roadway and bridge curb to curb width that you see in the right photograph are 30 feet with 1 lane of vehicular traffic in each direction. And there is a steel cable with timber post guide rail at all 4 corners of this bridge. And the pipe arches are overlain with about 4 foot 8 inches of soil, rock, and pavement. Regarding utilities, there are overhead electric and communication wires that span the structure on the north side of the roadway. And the town of East Lyme Water and Sewer Department have a water main, an 8-inch public water main that passes over the culverts just south of the roadway center line. The Connecticut DOT's inspection in 2022 indicated that the approach is in satisfactory condition with a rating of 6. The timber posts exhibit decay, splits, missing J-bolts, and some minor collision damage. The pavement exhibits numerous random transverse and longitudinal cracks, and the bituminous concrete curbs have cracks up to 2 inches wide. You could just make one out here where I'm pointing with the laser pointer. The older of the 2 metal pipe arches, again, which was built in 1968 or 1969, is called Span 1 in the DOT inspection reports. DOT rated the condition of these culverts as poor in 2022, primarily due to the condition of Span 1. This 55-year-old pipe has isolated rust holes up to 2 inches in diameter, and it has 3 metal patches in it, which you can see in the top row of photos. This pipe has a significant bulge in the top of the arch in the metal that is over 3.5 inches deep by 2.5 feet wide by about 6 feet long. Both arches, that is Span 1 and Span 2, have bottom corner plates with heavy laminar rust, pronounced thinning and penetration holes up to 1 inch in diameter, and the bottom plates have heavy laminar rust with pitting and thinning along the full length of the pipes. Nuts and bolts at, above, and below the water line exhibit rust with section loss up to 75%. The newer arch pipe, built in 1983, which is called Span 2, is missing several bolts on one side. The 2022 DOT inspection report gave the channel a rating of fair. It noted moderate stream bed scour downstream of the structure, moderate to heavy embankment erosion that is undercutting the embankments and exposing some of the plant roots, and there is some debris accumulation along the embankments. The purpose of this project is to address the poor structural condition of the existing culvert pipes in order to get this bridge into a state of good repair. The proposed replacement bridge will be a single-span concrete box beam superstructure on reinforced cast-in-place integral abutments. This bridge will consist of 33-inch deep precast box beams overlain with a 6-inch minimum concrete shear slab, membrane waterproofing, and 3-inch minimum bituminous wearing surface. The concrete integral abutments will be founded on piles, and the wing walls will be cast in place. The total structure length will be about 87 feet, with a clear span of about 78 feet. The overall out-to-out width of the new bridge will be 37.5 feet. The bridge curb-to-curb width will be 34 feet, and it'll carry 2 11-foot wide travel lanes, plus 2 5-foot minimum wide shoulders. The open metal bridge rail will transition to concrete end walls treated with form liners to give those concrete walls a stone wall appearance. The roadway work will include the relocation of existing drainage outfall pipes at each end of the bridge and reconstruction of a nearby driveway at one corner of the bridge, which you can see in yellow. As I mentioned earlier, no sidewalks are proposed on the bridge. And since there are no sidewalks in the neighborhood and the town doesn't have plans to add any sidewalks. This bridge plan provides a closer look of the proposed work. And that work will also include the relocation of the water main I mentioned earlier in the presentation that's in the middle of the road now. That'll be relocated alongside the outside face of the downstream beam in accordance with discussions that we had with the town's water and sewer department. A portion of Colony Road will be closed during the bridge work and traffic will be detoured around the work zone for the 6 to 8 month construction duration. The 2.4 mile, 5-minute detour will use State Route 161, which again is Chesterfield Road, and the detour will also use Egret Road, Sandpiper Lane, Cedar Brook Lane, and Brookfield Drive. This proposed road closure will allow the contractor to finish the bridge work more quickly and economically, and it will also be safer for the traveling public and the contractor's work crew if motor vehicles do not drive through the work zone during the project. We envision Brook water handling, culvert demolition, and bridge construction will be performed in 2 stages. In stage 1, a temporary cofferdam highlighted in yellow on this particular slide will direct flow through just the westernmost culvert only, while the eastern most pipe within the cofferdam area here will be removed in the dry. That is, there won't be water flowing through this area. The east abutment of the new bridge will also be installed, and this grading work and channel work will be completed within the cofferdam in the dry. In stage 2, the cofferdam will be configured as shown here so that all of the water will flow to the east side. And then the westernmost pipe that was located here will be removed. The abutment will be constructed and the channel will be finished, again in the dry behind the stage 2 cofferdam. After the temporary cofferdam and water handling devices are removed, the new bridge superstructure will be installed. 2 types of easements, construction easements shown in red and slope easements shown in blue, will be required to remove the existing culverts and build a replacement bridge. As you can see from this conceptual sketch, 4 properties will be affected by easements. The Connecticut Department of Energy and Environmental Protection did an initial review of this project, and they looked at their natural diversity database, and the DEEP indicated in a letter that the state-listed wood turtle may be affected by project activities, and the DEEP recommended herpetologist input and turtle protection measures. The DEEP Fisheries Unit also took a look, and they noted that Latimer Brook supports an annual run of alewife and is stocked annually with trout. The deep fisheries people also made recommendations to be incorporated in the project that include maintaining unimpeded fish passage. They suggested in-water work schedule limitations and water pumping schedule limitations. The environmental review request response from the DOT's Office of Environmental Planning noted the potential presence of the northern long-eared bat, which will necessitate OEP coordination with the U.S. Fish and Wildlife Service. And finally, an initial environmental screening by the DOT suggested that a more detailed field investigation be performed to verify whether any regulated or hazardous materials are present, which might require special handling or disposal. This slide shows the anticipated environmental permits required for the project from the town of East Lyme, Connecticut Department of Energy and Environmental Protection, and the United States Army Corps of Engineers. Town residents will have an opportunity to hear details about the project again at a future East Lyme Inland Wetlands Agency public meeting if they choose to attend it. And finally, construction is anticipated to begin in the spring of 2026, depending on the availability of funding, acquisition of easements or rights of way, utility relocations, and pending timely approval of the local, state, and federal permits that I mentioned a moment ago. This bridge work is expected to take 6 to 8 months to complete, typically starting in April and ending in September or November at the latest. And as noted earlier, the town of East Lyme will be reimbursed for 100% of the construction cost by the Federal Highway Administration and/or the state of Connecticut. I will now turn the presentation over to Zachary at DOT to discuss right-of-way issues. Zachary?
Thanks, Jim. My name is Zachary Garino, and I'm a project coordinator with the department's Division of Rights of Way. Our office is responsible for acquiring the proper rights needed for transportation projects. As Jim mentioned in the presentation, this project will require the acquisition of property rights. So I'd like to give a brief overview of our acquisition process. Before I begin, I'd like to mention that the specific impacts are still being finalized, and they may change as the design progresses, and that any required property rights will be acquired in accordance with Connecticut General Statutes, sections 13A 73 and 13A 98E, as well as the Uniform Act. And as Jim mentioned, we have the construction easements, which will be temporary, and the slope easements will be permanent in this case. So next slide. So the right-of-way acquisition process begins once a design has progressed to a development milestone and all the impacts have been determined. At this point, each affected property owner will receive a formal letter of intent to acquire from our office, along with a property map which depicts the exact property rights to be acquired. Now on the screen here is an example of a property map an owner may receive, has the existing conditions as well as the proposed improvements. Our office will determine the fair market value of the property rights which were depicted on this map and use that to establish an offer of just compensation. That offer will be sent out to the property owner in writing, and a right-of-way agent will be available to meet with the property owner and explain the project, go over the specific impacts to their property, and explain how the state arrived at its offer. The property owner will be given a reasonable amount of time, typically 30 days, to consider the state's offer and enter into negotiations. When an agreement is reached, the department will prepare all the necessary paperwork to record the deed and property map on the town land records. However, if an agreement cannot be reached, in order to keep on schedule, the department may acquire the necessary property rights to its power of eminent domain. In that event, the state files a notice of condemnation in the Superior Court, along with a monetary deposit in the amount of the state's offer. The owner would have 6 months from that date to file an appeal if they felt that the state's offer was inadequate. Whether or not the owner chooses to appeal, the money deposited in the court is available to be withdrawn by the owner. And it's important to note that the state only acquires property rights that are needed for this specific project. If there are any questions regarding the right-of-way acquisition process, I can answer them after the presentation. With that, I'll turn it back over to Mark for the Q&A. Thank you.
Thank you, Zach and Jim. At this point, we're going to conclude our formal presentation and open it up to your questions. You can reach out to us by email at dot-flbp@c2.gov, by phone at 860-594-2020, it's a monitored voicemail line, and through the Zoom Q&A chat during this presentation. And again, if you have any questions that come up after this presentation, comment period's open for 2 weeks. So you can still reach out to the project team. We'll be able to answer your questions.
Guys, I just want to let you know, I just checked the email and the voicemail. No questions as of yet.
We have a question from an anonymous attendee. Will the stream be widened to match the new span of the bridge? Jim Otis, would you like to take that question?
Sure. The new bridge will really be designed to fit the existing location for the most part. It'll have a bottom width and I can bring up a slide of 42 feet. That number is driven by the existing bank full width out there, which is 47 feet upstream of our roadway crossing and 37 feet downstream. And so the design team picked a 42-foot stream bottom width, which is the average of those two figures. And the bridge, based on requirements of the regulatory agencies, we have to provide a bank full width of 1.2 times the existing width. So we've provided a bridge that meets the existing conditions and complies with the DEEP and Army Corps of Engineers requirements for cross section.
Great. Thank you, Jim.
Mhm.
I have another question from anonymous. What is the impact of the stream flow past the new bridge? Jim Otis, you can take that question.
Well, we do have a preliminary hydraulic report, which is being reviewed by the hydraulic and drainage unit at DOT. And they're evaluating the report. I do recall, or I can tell you that the drainage area, this is considered a large bridge because the drainage area is 16.2 square miles upstream of the roadway crossing. And so based on the drainage area and the characteristics of the drainage area, we've computed some flows, which for design, in this case, the 100-year frequency event or 1% probability event, which is a requirement of the DOT for a large structure such as this. And our hydraulic report is being reviewed by the department. The design flow for this bridge is 1,930 cubic feet per second. That's the 1% or 100-year design flow.
Thank you, Jim. Yeah, we're going to stand for a couple more minutes to answer any questions that come up. Again, we encourage you to visit the project website and to fill out the voluntary post-attendee survey. Okay, not seeing any other questions come through. Once again, you have 2 weeks to ask the project team a question for us to be able to answer it. At this time, we're going to conclude our virtual public informational meeting. We appreciate your attendance and your questions. Thank you and have a pleasant evening.
Good night, everybody.
Good night. Thank you.